We are now ready to learn, or rather review, the first set of trigonometric definitions. The trigonometric functions defined in a right triangle. These trigonometric functions, sine, cosine, tangent, and their reciprocals, are defined for acute angles only. The skills you will need to master the content of this lesson are a basic understanding of geometry, in particular, some results about similar triangles. Let's begin by reviewing the typical labeling of a right triangle and the trigonometric terminology we associate with its sides. Okay, let's quickly draw a right triangle. Here we go. Let's call this the right angle, and let's label the vertices A, B, and C. Trigonometry deals with angles, so let's call this angle alpha and this angle beta. We know that alpha and beta in the right triangles are complementary angles. So in the right triangle, the opposite side of the right angle, which means this side, is called the hypotenuse. I'm gonna use a label HYP to denote the hypotenuse of the right triangle. The side next to the angle alpha that is not the hypotenuse is called the adjacent side of alpha. I'm going to use a label ADG of alpha. This means the adjacent. Adjacent means next to, right? So this is the adjacent side of alpha. And of course, the side that is the opposite side of the angle alpha then is going to be called the opposite of alpha. I'm going to use a label OPP of alpha. Okay? Now, in this terminology, I am referring to the angle alpha. But there is also another angle in the triangle, and that's the angle beta. So, if I use a similar terminology, but now for the angle beta, what can I write? Well, the side next to beta, that is not the hypotenuse, is called the adjacent side of beta. And we see that it's the same as the opposite side of alpha. And the side opposite of beta is called the, opposite side of beta. And we can see here that the opposite side of beta is the same as the adjacent side of alpha. Let's remember these relations. We will need it to state one of the first property of the trigonometric function. But now let's recall the definition of the first three trigonometric functions in a right triangle. Here are the definition of the sine, the cosine, and the tangent of an angle in the right triangle. In order to understand this definition, let's quickly draw a right triangle, like so. I'm going to assume this is a right angle. Let's call this vertex A, this vertex B, and the right angle, let's call it C. This is the angle alpha. So we know this is the adjacent side of alpha. Opposite of the right angle is the hypotenuse. And the opposite of alpha, well, it's called the opposite of alpha. Now, the adjacent, the hypotenuse, and the opposite, they represent the length of the side, okay? The adjacent is side AC, for example. The hypotenuse is the length of the segment AB, and the opposite is the length of the segment CB, okay? They represent lengths. Okay, so how do we define the sine of the angle alpha? It is equal to the opposite of alpha divided by the hypotenuse, the length of the side BC divided by the length of the side AB. How do we define the cosine of alpha? It's equal to the adjacent of alpha divided by the hypotenuse, and the tangent is the opposite divided by the adjacent of alpha. These definitions are fundamental and you must remember them. There is a mnemonic way that students have often remembered them by. It's SOHCAHTOA. Let's go over it. To use this mnemonic way, it is fundamental that you know how to spell the word SOHCAHTOA. SOHCAHTOA. SOHCAHTOA means sine is the opposite over the hypotenuse, SOH. Cosine is the adjacent over the hypotenuse, CAH. And tangent is the opposite over the adjacent, TOA. Now, before we go over some examples using this trigonometric definition, let's go over two remarks. The first remark is about the very definition of the trigonometric function and how they are not a function of the right triangle we are choosing. For example, Let's take a right triangle. Let's call this A, B, and C. This is the angle alpha. That's the opposite of alpha, the adjacent of alpha, and the hypotenuse. Okay. Let's look at the way we define sine. The sine of alpha is the opposite. I'm going to stop writing alpha here, okay? The opposite over the hypotenuse, right? Okay. Now, in this definition of the sine and also of the cosine and the tangent, I am using the length of the side of a triangle. So we may think that the value of sine, cosine, and tangents are a function of the length of the side of the triangle. Actually, they're not. They're just a function of the angle. How do we show that? Let's take a different triangle with the same angle alpha in it. So different triangle, I'm going to make the sides longer here, but the angle alpha, let's assume, is the same. So here we go right here. Let's assume this is alpha, and here vertex A prime, B prime, and this is my right angle. It doesn't look very right, that's okay. And this is C prime, okay? These two triangles are similar because they have three congruent angles. The angle at B is the same as the angle at B prime. And in similar triangle, we have that the ratio of the corresponding side is the same. So if you look at CB over AB, which is the sine of alpha, the opposite of alpha divided by the hypotenuse of alpha, this is going to be the same as C prime B prime over A prime B prime. And this would be the sine of alpha in this triangle right here. And so we have the same value for the sine of alpha. It is just a function of the angle due to the result of similar triangle. And this is true for the cosine and the tangent of the angle alpha. That's the first remark. The second remark is about the other trigonometric function that we can define in a right triangle. So there are three other trigonometric function. Let's assume this is a right angle. This is the vertex A, B, and C. This is the angle alpha, the opposite of alpha, the hypotenuse, and the adjacent of alpha. We define the cosecant of alpha, which is defined by the hypotenuse divided by the opposite of alpha. Now you can see this is a reciprocal of the sine of alpha. So it's 1 over the sine of alpha. We also define the secant of alpha as the hypotenuse divided by the adjacent of alpha. And this is the reciprocal of cosine alpha. And then we define the cotangent of alpha as the adjacent of alpha divided by the opposite of alpha. And we recognize here the reciprocal of tangent alpha. So we also have the three trigonometric function defined as the reciprocal of the sine, cosine, and tangent of the angle alpha. Let's go over the first set of examples. Okay. So here's the first set of examples. I am given a triangle with some lengths, and I'm asked to find the sine, cosine, and tangent of the indicated angle. Right here, the angle would be alpha, for example. I'm also asked to evaluate sine square of alpha plus cosine square of alpha. Okay, let's begin by looking at what's given. Here's my angle alpha right here. So what's given is the adjacent side of alpha and the opposite side of alpha. Let's write it down. So the adjacent side of alpha is 4 and the opposite side of alpha is 3. Now, I'm not given the hypotenuse, and I'm going to need it to compute the trigonometric value of the angle alpha. So let me call that x right here. And how can I find x? Well, that's using the famous Pythagorean relation in the right triangle. The sum of the squares of the legs of a right triangle. So this is a sum of the squares of the legs. So 3 is a leg, I need to square it. 4 is a leg, I need to square it. Is equal to the square of the hypotenuse. Here we go. And that will give us the value of x, right? So 9 plus 16 equals x squared. And so we have that x squared equals 25, which means x has to be a positive value, okay? X is 5. x is the hypotenuse, so the hypotenuse is 5. So now I can write the value of sine, cosine, and tangent of the angle alpha. What is the sine of alpha? It is the opposite over the hypotenuse. So it is 3 over 5. 3 over 5. What is the cosine of alpha? It's the adjacent over the hypotenuse. And so it is 4 over 5. 4 over 5. And the tangent of alpha, is the opposite over the adjacent. So it is 3 over 4. Here we go. I've answered the first question. I do have a second question. They ask me to evaluate sine square alpha plus cosine square alpha. So first of all, this notation right here with the power there means the sine of alpha squares plus the cosine of alpha squares. Okay? Now, what is the sine of alpha square? Well, it is 3/5 square plus 4/5 square. 3/5 square is 9 over 25 plus 4/5 square is 16 over 25. And so this is 9 plus 16 over 25, 25 over 25, which is 1. Wow, nice round number. All right, second example. Okay, in this example, what am I given right here? I'm looking at the angle beta. I'm given the adjacent of beta. The adjacent of beta is 3. And I'm given also the opposite of the right angle. That's just the hypotenuse in the right triangle. And this is 4. Now, what I'm not given is the opposite of beta. Let me call that x right here. And let's figure out x using the Pythagorean relation. So again, I'm looking for the opposite of beta. So what do we know about the Pythagorean relation? This is the hypotenuse. So the sum of the squares of the legs, so the sum of 3 squared and x squared, is equal to the square of the hypotenuse, 4 squares. Okay, let's solve that for x. So what do we have? We have 9 plus x squared equals 16. So that means that x squared is equal to 16 minus 9. 16 minus 9 is 7. So that implies that x is equal to the square root of 7. X has to be a positive number. It's a length. Okay. X was the opposite side of beta, so it is square root of 7. Oop, it looks like the y and the p are gone here. All right, I am ready now to write the trigonometric value of the angle beta. Sine of beta is the opposite over the hypotenuse. The cosine of beta is the adjacent over the hypotenuse. And the tangent of beta is the opposite over the adjacent. So what are these ratios equal to? The opposite over the hypotenuse is root 7 divided by 4. Root 7 divided by 4. The adjacent over the hypotenuse is 3 divided by 4. 3 divided by 4. And the opposite over the adjacent is root 7 divided by 3. So root 7 divided by 3. And then the second question is the sum of sine square plus cosine square. So sine square beta plus cosine square beta. Again, that means I'm going to take the sine of beta and I'm going to square it. So it's a square of root 7 over 4 plus the cosine of beta, 3/4, and I'm going to square it. So this is square root of 7 squared, that's 7. 4 square is 16, plus 3 square is 9. 4 square is 16. All right, so what is 7 plus 9? Well, 7 plus 9 is 16. So again, 16 over 16 is equal to 1. Well, that's the second time we find 1 when we add sine square and cosine square. Can it be equal to something different? Actually, it cannot. And we will prove that in the next lesson. Let's continue. So in the second set of examples, I am given a right triangle with some information, including an angle, and I am asked to find all the sides of the right triangle. Okay? Let's see how to do that. So what is given in this triangle? I'm given an angle of 35 degrees, and I'm given the length of the opposite side, 5 centimeters. So the angle is 35 degrees, and the opposite of the angle is 5. Okay? Now, what kind of trigonometric value can I write with an angle alpha and the opposite of alpha? Well, one of the trigonometric functions that comes to mind is the sine of the angle alpha. What is the sine of alpha? The opposite of alpha divided by the hypotenuse. Now, what do I know? I know alpha, so I can figure out the sine of alpha, and I know the opposite of alpha. So I can solve this equation for the hypotenuse, right? So this means that the hypotenuse is equal to the opposite of alpha divided by the sine of alpha, right? Please don't forget the quick way to work in a ratio. If A is equal to B over C, this is the same as C equal to B over A, okay? You multiply both sides by C and you divide by A. You quickly switch the roles of A and C. This is what I did right here. Okay, so with this, I can figure out the length of the hypotenuse. The opposite I said was 5, and the angle is 35 degrees. So it's 5 divided by the sine of 35. We need to take our calculator. First thing I need to make sure of is that my mode is degree. And I can see right here at the top that my mode is not degree, it is radian. Okay, so I got to change that. Let's go to mode. And here I want to make sure I'm in degree. So degree, enter. Here we go. I should be now quit. Yes, now I see degree. Okay, and the ratio I wanted to enter was 5 divided by the sine, right here. Here's the key for sine, of the angle that measures 35 degrees. Here we go. And this is, it's about 8.7172. The problem is asking me to round to the 10th, so it's about 8.7. Let's report that. So the hypotenuse is about 8.7. Actually, I like to write it here directly on the triangle, and this is about 8.7. Okay, now I need to figure out the adjacent side. And to do that, I'm going to use the other trigonometric function of the angle alpha, which is tan of alpha. Tan of alpha is the opposite of alpha divided by the adjacent of alpha. So again, let's switch the role of tan and adjacent. So we have that the adjacent of alpha is the opposite of alpha divided by the tan of alpha. The opposite is 5, and the angle alpha is 35 degrees. Here we go. Let's type this ratio in the calculator and figure out the length of the adjacent. 5 divided by 10 of 35, and this is 7.1. So this is about 7.1. And if you put that in the triangle right here, you have about 7.1. Let's not forget to write the units. This was given in centimeters. Here we go. I have found the length of all the sides in this right triangle. Next example. So in this example, what am I given? The angle alpha has a measure of 62 degrees. And then I'm given the opposite side of the right angle. So this is the hypotenuse. And the length of the hypotenuse is 5 inches. Okay? So with that, I need to find the side AC. AC is the adjacent, and the side BC, which is the opposite. So what are the trigonometric value that I can write with the angle alpha and the hypotenuse? Well, I can write the sine. The sine of alpha is the opposite of alpha divided by the hypotenuse. Now, what do I know here? I know the angle alpha, therefore I can figure out the sine of alpha, and I know the hypotenuse. So I can solve this equation for the opposite side, and the opposite side is the hypotenuse times the sine of alpha. Okay, so the hypotenuse was 5 times, and the sine of alpha, this is the sine of 62 degrees. Okay, I'm going to write the formula for the adjacent, and then I'll take my calculator. So to find the adjacent, I need to use the cosine of alpha, right? So we have cosine of alpha equals adjacent of alpha divided by the hypotenuse. So that means if you solve for the adjacent, you have that the adjacent side of alpha is the hypotenuse times the cosine of alpha. The hypotenuse is 5, and I will multiply this by the cosine of 62 degrees. All right, so now I can take my calculator. 5 times the sine of 62 degrees is this, and now 5 times the cosine of 62 degrees is, so we have 4.4 for the opposite and 2.3 for the adjacent. Okay, so this is about 4.4. Let me write the unit right here. And we said 2.3 for the adjacent. Okay, 4.4 inches and 2.3 inches. Next set of examples. In the next set of examples, I am given a trigonometric value and I am asked to find the other two. So in number 6, I'm given the sine of alpha. I have to find the cosine and the tangent of alpha. And then I'm also asked to find the value of sine square plus cosine square. All right, so how do we do that? Well, I need a right triangle, right? So let's draw a right triangle quickly right here. Here we go. This is going to be my right triangle. My right angle is going to be right here. And I'm going to put my angle alpha here. What is the sine of alpha? The sine of alpha is the opposite of the angle alpha divided by the hypotenuse, right? This is the opposite. So I'm going to say that this length right here is 2, okay? And I'm also going to say that the length of the hypotenuse is 3. Remember, the trigonometric value of an angle is not a function of the length of the sides of the right triangle. I could have taken 4 and 6. It doesn't matter. Okay, so I need to find the cosine and the sine. Therefore, I need to figure out the adjacent side right here, where we're going to be using the Pythagorean theorem for that, right? So the sum of the squares of the legs, so it's 2 squared plus x squared, is equal to the square of the hypotenuse, 3 squared. Okay, let's solve this equation for x. So we have x squared equals 9 minus 4. 9 minus 4 is 5, which means x is equal to the square root of 5. Okay, I have figured out the length of the adjacent, square root of 5. And so now I can write the two other trigonometric functions I am asked to find, which is cosine of alpha. Cosine of alpha is the adjacent divided by the hypotenuse, root 5 divided by 3. And the tangent of alpha is the opposite divided by the adjacent, so it is 2 over 3. All right, let's also evaluate sine square plus cosine square. So sine square alpha plus cosine square alpha is equal to, okay, so the sine was 2 over 3, 2 over 3 squared, plus, and the cosine is root 5 over 3, root 5 over 3 squares. So this is 2 square, 4, 3 square, 9, root 5 square, 5, 3 square, 9. And again, 4 plus 5 over 9, well, that is 1. Here we go. Let's do another example like that. So in this example, I am given the tangent of an angle alpha. Now let's draw a right triangle right here. All right, let's put the right angle here. And the angle alpha, let's write it here. Now the tangent is the opposite of alpha divided by the adjacent of alpha. So the opposite of alpha, how do we understand 2.5? Well, this could be 2.5 times 1, right? But then the opposite 2.5, the adjacent 1, a decimal is not a very practical value to square, right? I'm going to have to square it to figure out the hypotenuse. So instead, I'd rather multiply both sides by 2 and look at the triangle with an opposite of 5 and an adjacent of 2. 5 over 2 is 2.5. And this is going to be a better triangle to play with. 5, 2. So let's call this side x right here. How do we find x? So x squared is 5 squared plus 2 squared, right? So it is 25 plus 4. 25 plus 4 is 29. And so we have x is the square root of 29. So x right here is the square root of 29. Okay, now I can write my trigonometric value. What is the sine of alpha? Well, the sine of alpha is the opposite divided by the hypotenuse. So it is 5 over square root of 29. What is the cosine of alpha? The cosine of alpha is the adjacent divided by the hypotenuse. So it is 2 divided by square root of 29. Finally, what is sine square alpha plus cosine square alpha? Well, it's going to be 5 over root 29 squared plus 2 over root 29 squared. And so this is 5 squared, 25, root 29 square, 29, plus 2 square, 4, root 29 square, 29. And again, 25 plus 4 is 29. 29 over 29 is 1. All right, now let's go over some fundamental trigonometric values. Before we do so, we need to recall an important result from geometry about a 30, 60, 90 triangle and a 45, 45, 90 triangle. It is about the relation between the length of the sides in this triangle. In the 30, 60, 90, the length of the long leg is root 3 times the length of the short leg, while the length of the hypotenuse is twice the length of the short leg. So in both cases, I'm given the length of the short legs and I can deduce the length of the other two. In a 45, 45, 90 triangle, this is an isosceles triangle, right? The length of the hypotenuse is root 2 times the length of one of the two legs. The legs will measure the same length. Let's illustrate this property. So what does the result say? So suppose the length of the short leg is x. It says that to go from the short to the long leg, you multiply by root 3. The length of this side is x times root 3. And to go from the short to the hypotenuse, you multiply by 2. The length of the hypotenuse is 2x. I hope you remember this result. It's a fundamental result from geometry. Of course, if you want to go from the long to the short, then you'll divide by root 3. And if you want to go from the hypotenuse to the short, you'll divide by 2. Okay? All right. In a 45, 45, 90, well, that's an isosceles triangle. So let's call the length of the legs x. They have the same length. It says that to go from one leg to the hypotenuse, you multiply by square root of 2. So the length of this side is x times root 2. Okay, so how can we use this result to evaluate the trigonometric value of the angle 30, 60, and 45 degree? Well, remember that the trigonometric value of an angle is not the function of the length of the sides of a right triangle. So I can take right here, instead of x, I can take 1. I can say the length of the short side is 1. If the length of the short side is 1, then what are the length of the other side in this triangle? Well, you multiply by root 3 to find the long side. So 1 times root 3 is root 3. And you multiply by 2 to find the hypotenuse. 1 times 2 is 2. I'm going to do the same thing with this isosceles triangle. I'm going to say the length of the legs is 1. And so the length of the hypotenuse is going to be square root of 2. Okay? And with that, then I can get the sine, the cosine, and the tangent of 30, 60, and 45 degree. Let's do that. So let's start with the angle 30 degree. What is the sine of 30 degree? So 30 degrees right here. The sine is the opposite over the hypotenuse. So it is 1/2. What is the cosine of 30 degree? The cosine is the adjacent over the hypotenuse. So it is square root of 3 over 2. And what is the tangent of 30 degree? It is the opposite over the adjacent, so it is 1 over square root of 3. All right, that was for the angle 30 degree. Now let's look at the angle 60 degree. I've erased my length, 1, 2, and root 3. Okay, so now for 60 degree, what do we have? The sine of 60 degree, 60 is right here. The sine is the opposite, so it is square root of 3 divided by the hypotenuse, 2. The cosine of 60 is the adjacent. So the cosine of 60 degree is the adjacent, 1 divided by the hypotenuse, 2. And the tan of 60 degree is the opposite divided by the adjacent. So it's square root of 3 over 1, or just square root of 3. That's it. This is for the angle 60 degree. This is for the 30, 60, 90 triangle. Okay. So now let's work in the 45, 45, 90 triangle. Let's look at this angle, for example, and let's get the cosine of 45 degree. The cosine of 45 is the adjacent divided by the hypotenuse, 1 over square root of 2. Very often you will see this ratio rationalize. So you multiply both sides by root 2 and it becomes square root of 2 over 2. Personally, I don't mind 1 over root 2. The sine of 45 degree, so the sine is the opposite. Oh, it looks like I've lost this side right here. The sine is the opposite right here over the hypotenuse. So it is 1 over root 2. Same value, so it is root 2 over 2. Okay, now I'm losing all the sides, right? 1 and 1 right here. All right, let's erase maybe too much stuff written right here. And the tangent of 45 degree, tangent of 45 degree is, tangent of 45 is the opposite divided by the adjacent, 1 over 1, which is 1. These results are so important that you have to be able either to remember them by heart or to find them quickly. Let's recapitulate them. Here they are. You have right here this chart that gives you the trigonometric value of the angle 30, 45, and 60. I've also added the corresponding radian angle. Remember, radians is actually much more important than degree in math, okay? 30 degree correspond to pi over 6, 45 degree correspond to pi over 4, and 60 degree correspond to pi over 3. Make sure you can either remember these results by heart or figure them out quickly. Let's do one more example. Okay, in this example, I'm asked to find the value sine 30 degree times cosine 60 degree plus sine 60 degree times cosine 30 degrees. So suppose I don't remember the value of sine 30 and cosine 60 and so on. I'm going to draw quickly a right triangle. The small angle will be 30 degree while the larger angle will be 60 degree. I'm going to assume this is a 30, 60, 90 triangle, right? And then I'm going to say the short leg is 1. Now, the result from geometry must be remembered. You multiply the short leg by 2 to find the hypotenuse, and you multiply the short leg by square root of 3 to find the long leg. Here we go. And so with this triangle right here, you can decide what's the sine of 30. The sine of 30 is the opposite divided by the hypotenuse. So it is 1/2. What's the cosine of 60? Cosine of 60 is the adjacent divided by the hypotenuse. So it is 1/2 also, right? The sine of 60 is the opposite, square root of 3 divided by the hypotenuse, 2. And the cosine of 30 is the adjacent of 30, square root of 3 divided by the hypotenuse, 2. So what is this? This 1/2 times 1/2 is 1/4 plus square root of 3 times square root of 3 is 3. 2 times 2 is 4. 1/4 plus 3/4 is 1 plus 3 over 4, which is 1. All right, I hope this lesson was clear. Thank you for watching.